Hello guys, this is the TI-84 guy again. Continuing with the second part of the series of program or videos that I wanted to do on using this program that I've written for the SAT, ACT, Math Level 1, Math Level 2 subject tests. Alright, the very first video I showed you how to use the program ASEQUERY and for sequences and series. The program also has a variable portion if you have variables in the sequence that you need to solve for. So I want to just demonstrate how you would use that with this second series of videos. So let me get a timer because I keep going over on my time. So I want to make sure that this one is not too long. So I'm going to get my trusty timer here and go. Alright, so very first question. It says, in the arithmetic sequence above, the first term is g, the second term is 2g plus 7, and the third term is g plus 6. What is the value of the fourth term in the sequence? So essentially, they've given us three terms, and each term has a variable in it. So what I would do is, and I'll show you here, turn it on. I'm going to go find the program ASEQUERY, press enter. All right, now, very first question, does this sequence have a variable in it? Yes, it does. So we're going to choose option 2. Boom. All right, now, we know that this is an arithmetic sequence because the problem says that it is. All right, so we're going to choose option 1. So the very first term, we're going to put in 1, and then we're going to put in. Now the program has been written to identify or expect only x's as variables. So you can't use a g, you have to use an x. All right, next thing, second term is 2x plus 7. The third term is x plus 6. Before I press enter, I want to make another point or reiterate a point that I made before. On the last video, I said that in order to generate any sequence, whether it's arithmetic or geometric, you need to have a minimum of 2 terms and know the values associated with those terms. All right. If you are dealing with a variable, a sequence that has a variable in it, whether it's arithmetic or geometric, you need to have a minimum of 3 terms, all right? And this problem has given us 3 terms, all right? So we're all set. So now that we've entered the 3 terms, let's just go enter. All right, now, the program is gonna ask you to kind of help it out as it starts to kind of search for the value for x. You can put pretty much anything in here, but I would use your answer choices as a guide. Generally, it's a good idea to go with the middle term. So we'll put in 5, press enter, and then so the program comes back and says that the value of x is a -4. So that means that the very first term here is a -4. The second term is a -4 times 2 plus 7, which would be a -1. And then the third term would be a -4 plus 6, which would be 2. So it's a -4, -1, -2, and now we have to find the fourth term. An easy way to do that is just to use the table feature. Let's see what we got here. It says what we expect. The very first term is a -4, the second term is a -1, the third term is 2, and the fourth term is 5. So the answer to this particular question is 5. All right, so let's keep it going. Next problem. All right, it says, what number should be added to each of the 3 numbers, a -1, 10, and 32, so that the resulting 3 numbers form a geometric progression? So what it's saying is, you have 1, 2, 3 terms, you have a -1 here, you have you have 10 here, and you have 32 here. And they're saying if you add a number or the same number to each one of these, the resulting 3 numbers will form a geometric progression. So So let's go, and we're going to use this program again. Okay, does this have variables? Now, the numbers itself doesn't have any variables, but now that we're trying to find what number we should add to each one of these, we can say, okay, let's let that be x and let's solve for it. So indirectly or implicitly, we have a variable. So in this case, it's going to form a geometric progression. So let's go with the geometric progression, which would be option 3, geometric sequence. Okay, so the very first term, make sure this is in here, is 1, and it's going to be negative 1 plus x. And then it's going to be 2, second term is 10 plus x. Third term is going to be 32 plus x. It's going to ask you for a guess. Let's use the middle term, 12. See what we get here. So it says actually that the value that you would add would be 12. So let's see about that. So if we add 12 to this would be 11. If we add 12 to this, it'll be 22. If we add 12 to this, it'll be 44. So you can see that this is increasing by two times. So 11 times 2 is 22. 22 times 2 is 44. So in fact, this is a geometric progression. And so the answer would be 12. Okay, let's keep it going. The next question. It says, okay, if you have an arithmetic sequence of a -2, 5, and 12, then what term has a value of 124? So let me write this again. -2, 5, 12, and then ... you got 124 out here. So this is the first term, second term, third term. We want to know what term has a value of 124. Okay, we can use our program again, and we can let this question mark be x, and so now we have a variable there. So press enter. So we're going to choose option 2. This is an arithmetic sequence, so we choose option 1. The very first term is a -2. The second term is 5. Now, we're not going to use this term. We're going to go out here because we need 3 terms, remember? So we're going to let this be x. We're trying to find the term, and the value we know is 124. So press enter. Okay, we're going to take a guess. Let's say 19. All right. So it says it is actually 19. So they're saying that this is the 19th term. Now, if we want to double check that, let's go look at the table. All right, so it says the very first term is a -2. The second term is 5. The third term is 12. What we want to know is if we go up to 19, do we get 144 or 124? And we do. The 19th term is 124, so this is correct. All right, next one. Where are we here? All right, it says, find the sum of the following arithmetic series. 5 plus 9 plus 13 plus ... plus 101. What's the sum of this? That's what we're trying to find. What's the sum of this? All right, so you know, this is a first term, second term, third term. We don't know what this term is over here, so we need to find that. So there, so again, we can let that be x. I'm going to combine these two things because we need to find the sum, the actual sum of this. But before we can find the sum, we need to know how many terms does this particular arithmetic series have. So let's press enter. All right, now what we're going to do is we're going to say yes, it has a variable that we need to solve for. And now instead of choosing the arithmetic sequence and finding this, we're going to combine them. We're going to find the sequence first, and then we're going to use whatever we find to then find the sum. So we're going to choose option 2. So so we press that, and it's going to ask for the term. We can go 1. First term is 5. The second term is 9. Okay. And then it's going to ask for the third term or the next term, and we're going to put an X because, again, we don't know what that term is. We don't know what the term is that is associated with 101, but we're going to find that. So we press enter, and we get, it's going to ask for a guess. So we'll take a guess, and let's say 15. I just made that one up. Okay, so it told us, it was only there for a second, but it said that the term associated with this is actually 25. So now that we know that the term is 25, we can go back here and go, okay, we're going to start the series at 1, and we're going to go to 25, and it tells us that the total is actually 1325. So that's this. Now, it only stayed there for a second. So if you didn't see that, then you'd probably have to do it again, or you'd have to do it basically just as a sequence and find out what the term is and then run it again as a series. But I tried to combine the two. Now that I've chosen something, I can go here and actually look to see if I go to the 25th term, it actually is 101. All right, so I was right there. So it is the 25th term. When you add up from 1 to 25, you get 1325, so we're done there. All right, we got two more problems here. This is going on. This video is going a little longer than I wanted it to, but let's keep going. All right, it says, how many terms of the arithmetic sequence will give a sum of 441? This is basically the same kind of problem that we just looked at. So let's go here. So we want to know how many terms do we need using this sequence to give us 441. So in this particular case, we don't need to use the variable portion, and I'll show you why. Okay, so now we're going to press no. This is an arithmetic sequence, but we want to find the sum, so we're going to use the series piece. So we're going to go option 2. The very first term is 1. The second term is 3. Now it's going to ask you, what do you want? Do you want the sum or do you want the number of terms? We actually want the number of terms. So we're going to choose option 2. And then it's going to ask you, well, what's the sum? Well, the sum is 441. So you put that in, press enter, and then it's going to tell you, well, that means that there must be 21 terms. So that means the choice here is 21. All right. Now, I didn't use the variable piece per se, although it does have a variable piece in there. But the way that I've coded the program, it's just going to ask you, okay, do you want to know the number of terms? If so, then you have to tell me what the sum is, and then I can find the number of terms. Okay, pretty easy. Okay, last one, and then we're done here. And then there's one more video, at least one more video coming on. Okay, so the next problem. This one says, the top of a pyramid has 1 Coke can, and each lower row has 2 more cans than the row above it. Okay, if the pyramid has a total of 100 cans, how many rows are there? Let me first draw this so that you can have an idea. So we have a Coke can here, and then we have 2 Coke cans here. Then we have 2 more Coke cans here. So this row has 1, this row has 3, and then we would go, okay, now these are supposed to be Coke cans. This row has 3 in it. The second row has 3. The third row has 5. All right. So what we want to know is if there are 100 cans all together, how many rows do we have? All right. So how many rows? So this problem is very similar to this one. All right. It's a word problem, but what you're essentially doing is what we were doing here, trying to find out how many terms there are. So we would press, does it have a variable? No. All right. We're saying it's an arithmetic series. The very first term, very first row has 1 can. The second row has 3 cans. Okay. And then it's going to say, what do you want to know? How many terms? Because we know that the total number of cans is 100. So we're going to go to option 2. And we're going to put in 100 for the sum, because that's the total number of cans. And then it's going to tell us that the total number of rows is 10. So we're done. All right, so this is this concludes this video. And basically this shows you how to use the variable portion of this program. All right, hopefully this is pretty clear. I hope you think it's useful. If you have any questions, leave a comment. If you like it, subscribe, and look out for the next video. There'll be one more video where I kind of show you how you can use this program on some non kind of arithmetic or geometric problems. All right, thanks.